Good afternoon, everyone. My name is Isaac, and today we will be reviewing our exercise portion for Chapter 7 on inheritance. Inheritance. This is for the LC101 Java track, and we're just going to go ahead and jump into it. So today we're actually going to be creating our own classes and adding a new package. So for now, we're just going to read through our assignment and what we need to do. So work on these exercises in the IntelliJ Java Web Dev exercise project. Add a new package called technology to your exercise. We're going to be doing some class design. We need to create a new class called computer. Before we add any more code, we will need to add two additional classes, laptop and smartphone. And prior to starting to code anything inside of these classes, we need to diagram how the three classes are going to be related to each other. Remember to add properties and methods to your diagram. For the parent, we're going to add three properties, two methods, and a constructor. And for a child class, we need to add at least one additional property and one additional method. So simple enough. And we're just going to go ahead and review the diagram section once more, just to make sure that we have it, which is right here. We need to diagram the top with the class name, middle with fields, and bottom with methods. And we're not going to be doing this piece right here. We're going to be doing the is a diagram, where a laptop is a computer and a smartphone is a computer technically as well. So I'm just going to go ahead and pull up the information that I already have. Just keep this in mind that you're going to be doing the top with the name, the middle with the fields, and the bottom with the methods. Go ahead and pull this up. We have the top with the names, bottom with the fields, and we're actually going to do this. Let's insert a new shape. I'm going to insert an arrow. We're going to connect these two like so. So a laptop is a computer. And we're going to insert another one. This one is going to be slightly squiggly. Nope, that's not going to work. Yeah, we're just going to delete that. Yeah, sure, why not? Anyway, you get the gist. We're not going to worry too much about where our arrows are because I apparently cannot draw today. So we have a computer. Now let's look at the fields that a computer would have. So between me, a computer has to have a processor, but I don't think we want to get that granular into it just because processors you can have i5s, i7s, Ryzen's, etc. So we're just going to omit that. A computer needs storage space, and storage is usually in like ints. So we're going to, well, 32 gigabytes, 1 terabyte, etc. So it's usually relatively small amounts, even though they can actually have bigger capacities. So we're just going to do int storage. We're also going to do, really? Okay, F2. So we're going to do int storage. The joys of Excel. There we go. Okay. We're going to do int RAM. And we're going to do, what else could a computer have? Computer could have storage, RAM. Computer could also have graphics card. Let's just do, I want to do string graphics card. And I'm just putting these names kind of loose. We're not actually going to do the capitals. And we're just going to check if it has RGB. Because, RGB makes computers run like 25% faster depending on the color of the lights, which is amazing. And our getters and setters are going to be a little different here, just because we theoretically can do a getter for storage, RAM, graphics card, and as RGB, just to confirm they're there. But we can also do I don't know if we would do setters for storage, RAM, graphics card, and RGB, because it's not something that's going to change. It should already come configured. We might do like an increase storage, increase RAM, and toggle RGB, because sometimes we just want to run an incognito. So simple enough computer, nothing too fancy. Oh, and we need a constructor. Okay. Now we're going to look at our laptop. Now, a laptop is essentially a mini computer, so it's going to have certain things, but it might not have other things. So we can use int storage. All laptops have storage. Use joys of Excel. Int RAM. All laptops have, well, yeah, all laptops have RAM. What else can we can do? String graphics card. And the one thing, laptops might not necessarily have RGB, which is okay. We're not worried about it. But laptops will also have a weight. Now, with a regular computer, you don't have to worry about the weight because it's, a tower. You're not carrying this thing around. But with a laptop, you would. So we're going to do an int weight. Now, for the getters and setters, they're going to be fairly simple. Same stuff right here, except instead of has get RGB, we're going to do get weight. Those are going to be our getters and setters. And actually, can we just copy and paste this? Yeah. Get storage, RAM, graphics cards, and weight. And we really only need one extra method. So for our child classes, so we're going to do is clunky. And we'll have our constructor. Simple enough. Now for smartphones are fairly similar to computers. So we're going to do int storage, int RAM. The one thing that smartphones might not have is a graphics card because, we're not quite there yet. Someday, hopefully, but not quite there yet. One thing that we do have in smartphones is apps. So int num of apps. And another thing that we could have is photos, int num of photos. Okay. So we can do standards, getters, setters, and constructor. Except instead of having a graphics card and a weight, we're actually going of apps and of photos. And for our phone, we might need something different than being clunky. So we could do a take a photo action, which will then increment our num of photos plus plus. And then we can do just a scatter for our numbers of photos, which we already did. So I think that this should cover us pretty well. Yeah, honestly, this should work. So now we're going to actually check the next piece, which is implementation. Implement your design and test in a program.java class. Try to add 3 JUnit tests per class. So we're just going to go ahead and do this. We're going to open up our Java project, this up, and we're going to do this. Okay. So exercise, we're going to do a new package, and we're going to call this package technology. Okay. And it's going to go ahead and create a new Java class called computer. And we're not going to add to get right now. So just looking at our computer class from here, we need to have a private int for storage, private int for RAM, a private string for fix card, and a private boolean for as RGB. I'm going to call it all lowercase because we're not. Okay, let's see what you want to do. I guess I have to do has RGB. Okay, so I'd like that. Okay, so we're fine with that. And we are just going to do our constructor, which is going to be generate structure. We're going to use everything. Okay. So we have everything already assigned here: storage, RAM, graphics card, and RGB. Simple enough. We're going to go ahead and do our getters and setters as well here. Right click, generate, and for now, let's just do our getters. We're not upgrading this computer manually because in this dystopian world, the computer is melded together. Okay. And we're going to do a couple of more things here. We're going to do a public void. Oh, public void increase RAM. So this is like RAM number. Okay. So when we want to increase our RAM, we're just going to do this dot RAM RAM plus RAM number. And what this will do is this will just help us increase our RAM as we go along, because RAM is a fairly simple thing to upgrade in this dystopian world. Even though I just said that everything was welded, we're just going to ignore that last part. And we're also going to increase our storage because everyone knows that 1 TB used to be a lot and now it's barely anything to scoff at. So increase storage int storage num, and this dot storage to this dot storage plus storage num. Okay, so let's look back at our assignment. We have 3 properties, 2 methods, and a constructor. We actually have a lot more than that. We have 4 properties, we have a constructor, and we have 2 methods here, and then a bunch of getters. So we're fine with that. Let's just go ahead and test this. And it said to test this in a program.java. So we're going to do Java class. We're just going to call this program. And we're not going to add that. So we're going to do computer bios is equal to a computer. And this one is going to have 500 gigabytes of storage. It's going to have 16 gigabytes of RAM. It's going to have a 3070 Force RTX 3070, and it will have RGB because we're cool like that. Okay, so for now, we're going to do, actually, should have been in main class. Button, there we go. And what we're going to do is we're just going to do out. We're going to do Helios dot get RAM and get storage. The current storage is plus Helios dot get storage. We're just gonna copy this piece of code. Get RAM here. Okay. And now we're actually going to call our methods to test them. So we're going to do Helios dot increase RAM, and we're going to and let's do Helios dot increase storage. We're going to increase storage by 250, and we're going to increase RAM by another 16. So let's just copy this and paste this. And okay, so we're just gonna go ahead and hit play. So as you can see, we started with 500 gigabytes of storage and 16 RAM. Then the new storage, we bumped it up by 250 to 750 gigabytes, and the new RAM is 32 gigabytes. So our computer class is working as expected. Now we're going to go ahead and create our child class of laptop. And laptop is going to actually extend computer, actually extend computer. Okay. And what we're going to do with the computer is this computer is going to have its own private double of weight. Okay, fine. What seems to be the problem here? Oh, well, we don't have a constructor matching super. Okay, so let's just go ahead and continue. And let's see. We're going to go ahead and create our constructor. So public laptop. Actually, IntelliJ is smart enough to help you with this itself. So it's going to go ahead and do a new constructor. And as you can see here, it's already pulling everything in, but we've already said that laptop might not necessarily have RGB. Yeah, we'll just go ahead and include it anyway. So we're going to go ahead and do this dot weight. Okay. And there you have your constructor for public laptop. So remember, with this super keyword, we are accessing the constructor in our computer program and accessing all of this without having to directly access it in here. So we'll just go ahead and continue as is for now. And we need our getters for all of our information. And let's remove it. Okay, so looks like all of our parameters need to match, so we'll have to keep RGB. Actually, you know what? No, let's go ahead and remove RGB. We're doing a stealth build, no RGB. We're gonna go ahead and remove that fourth parameter for computer. All right, let's go see what's wrong with our computer now. Start RGB. I think that should be it. Now when we come back here, all right, we're rocking and rolling. So we've done all of this. Now we need to actually see do our getters and setters. Pick refactor. Well, not refactor. We're going to generate our getters. And one thing to note here is we're only being given the option to do a getter for weight. That's because remember, we're also, since we're extending computer, we should have access to all of the setters in here as well. All of the getters. Ugh. Okay. Let's continue. Now we need to implement our is clunky. So we're going to do public boolean is clunky. And what will happen here is we'll do a weight check. If weight is greater than 15 pounds, then we will return true. Else, return false. And this just checks the weight, saying, hey, if it's heavy, return true. If it's not, return false. Simple enough. And let's actually let's generate a new laptop in our program.java. We're going to do laptop Helios is equal to laptop. That's going to be a 500 gigabyte storage, 32 gigs of RAM, and a RTX 3060 Ti. And I think we're missing one more piece here. On our laptop. So we did forget one thing. Int double weight. There we go. Back here. And we're going to pass in the weight on this one, since it's a heavier laptop, is going to be 20 pounds. Okay. So we're actually going to comment this out so we don't run into some errors with our computer class. I'm going to enter here so we can see everything in one line. Okay. So now we have our laptop, and just running a couple of tests. Let's do print out, and we're going to do Helios dot is clunky. And just to confirm, we're going to print out Helios dot get weight. And why not? Let's just print out the get graphics card. And we're just going to run this. And when we run this, we have is clunky true because it's 20 pounds, and we have the graphics card. Now remember, we don't have an explicit get graphics card class here in our Java, in our laptop Java, but we do have it in computer get graphics card. So since we have it in here and laptop is extended from Java, we have absolutely no problem accessing that method. Okay, now we're going to do our smartphone. New Java class, and this one will be smartphone. Okay, cancel, and going to make this one extends computer, and it's already giving me an error saying that I need a constructor that matches super. So we generated that, and we're actually going to, oh really? I will leave it, why not? Okay, we're going to also put in an int num of apps and an int num of photos. Okay. And this dot private int num of apps and private int num of photos. Okay. So this dot num of apps equals num of apps. This dot num of photos equals num of photos. Okay, so there we have our constructor. And going to go ahead and our getters, well, yeah, go ahead and generate our getters for our number of apps and number of photos. Okay. And now we're going to create our methods for take a photo, which should be to do public void take photos, take photo, which will then do this dot num of photos equals this dot num of photos plus plus, and we're just going to do a very generic counter for this dot this dot num of apps is equal to this dot num of apps plus plus. Okay, so now we need to actually go into our program, and we're going to comment this out. We're going to scroll down. We're going to do smartphone Samsung equal to new smartphone. Yes, we do stand Samsung here, just letting y'all know that. And we need our, I know we need 5 arguments. So we need storage space can be 500 gigabytes. Our RAM is usually like 16, honestly. Okay. Our graphics card, we might not actually have a graphics card, so we're just going to put N-A. I know that there's specific chips for it, but we're just going to say, hey, no graphics card in this. Number of apps, we're going to say we have 32 because of bloatware. And for number of photos, we're going to say we have 521. Okay. So now we're going to actually do a couple of things. First, we're going to console.log or system print out, whatever, our current number of photos, which is Samsung dot get number of photos, and look like this. Oh, and dot get number of apps. Okay. Now we're going to do. My apologies for the alarms. Now we're going to do Samsung dot download app and Samsung dot take photo. And what we're going to do is we're just going to copy these and paste these again. And let's see what happens now. So we started with 521.32 and we ended with 521.22. Interesting. So something in our smartphone class is not working correctly. Maybe the plus plus or the fact that there's a space there. It could be something as simple as a mistake like that. Let's try running it now. Let's just explicitly call a +1 here and a +1 there. And let's try running it again. Okay, that time it did work. So we just needed to explicitly call a +1 instead of incrementing doing plus plus. So simple enough. So now we have all of these methods, and let's just check to see if this actually did inherit anything from computer. So we'll do Samsung dot. Yeah, we can get storage, we can get RAM, we can get graphics card, storage. Yeah, 500 gigs. So these are all successes. Our computer is our parent class, our laptop and smartphone are our children class, and it looks like our all classes are functioning as expected. Let's look back at our assignment. And now we need to do some abstract class assign. So considering the group of classes that we've designed, suppose we had a web program that used these classes and we needed to assign a unique ID to every object created from one of these classes within the application. Therefore, each subclass should have an ID property, and no two objects from any classes may have the same value for ID. Create an abstract class, abstract entity, that contains the behavior for assigning and accessing such a unique ID for each class that extends it. Add this program above and add abstract entity to the class hierarchy in the correct place. Okay, so we're just going to do this, abstract entity, copy. We're going to go into our program going to do a new Java class, and we're going to paste. Not going to add anything there. We're fine. And our class has to be abstract. So we're going to do abstract class abstract entity. Now we're going to do two pieces here. We're going to do private int ID. We're going to do private static int count, which will initialize to 0. Now, you could theoretically do something really fancy with this, but honestly, just an incrementing ID counter should be more than plenty for this. And we're not too worried about getting uber fancy with it. This is just a quick ID. If you wanted to have truly unique IDs generated, you would probably want to use a SQL backend or something that could generate these keys for you. But for now, we're just going to do this. So we're just going to go ahead and create a constructor here. Generate structure. Okay. So public abstract entity, which this one actually takes an int ID, and we don't want that. So what we would want to do is we would want to do this dot ID equals count plus plus count. What this will do is this will add the count number here, and we're going to actually want to do a public int get ID. And we're going to return this dot ID. Okay, so now we have a way to get an ID, a way to get a new counter up here. This counter will automatically update with the... I swear I usually don't record this early. This is why all these alarms are popping off. I really need to silence my phone. Actually, let me do that real quick because this is getting kind of annoying. Okay. So now that we have all of these pieces done, we have public abstract entity, which assigns the ID and increments the counter, and we have a way to return our ID. Now, how do we implement this across our computer program, our smartphone, our laptop, and our regular program? Well, what we would want to do at this point is we would actually want to implement this into the parent class. So we're going to go to computer, and we're going to do computer extends abstract entity. Okay. And I think that's all you have to do. Yeah, let's check it out. I mean, why not? Let's do out some dot get ID. And let's just uncomment all of these out. Helios 1 computer. Even need all of this, honestly. Dot get ID. It's giving me text box. Is it because I put it all in one line? It is because I have no idea actually. All right, fine. What's wrong? That's why. Actually, go ahead and remove this. Yeah, that's actually fine. Print out Helios dot get ID. Okay. And we already have Samsung.getID down here, so let's try running it and see what happens. Computer cannot be applied to given types. Required int. Graphics. Did this fail, I wonder? Helios computer is equal to a new computer. Storage 500. RAM 32. String graphics card 70. Oh, I guess I had an extra argument there. And yep, our IDs are being increased by one every time we go, so they're unique. We should never have an overlap there. With the implementation of incrementation, the way I did it, we might have some overlap, but currently all of these are unique. We are meeting, and the abstract class that we extended in program is actually the abstract class that we extended in computer is extending to all of the child entities, well, child classes as well. So all of them have access to, where is it? This, there we go, to this ID and this counter, and they can all assign it manually. So let's look back at here. And I do believe that that actually finishes out our exercises. So if you have any questions or concerns, please feel free to reach out. But I do believe that with that, we have completed our exercises on inheritance. If you have any questions, please leave a comment. Please reach out to me directly. Uh, yeah, that's all we got. Have a great one. Stay safe.